Assuming you put it where the sun is, it would relax to the circle of Jupiter, a beast absolutely precarious and going to detonate. They are among the most unmistakable effects of radio energy in the whole universe, conveying more energy than a billion suns. Bug Jew, or startling crawly Jew, is a red Goliath star. If you put it where the sun is, it would interface with the circle of Jupiter. Huge, totally flighty, and additionally going to detonate. When we consider stars, we probably envision negligible glimmering things in the night sky. Fundamentally, this is the manner in which we see them from down here on Earth. Yet stars are something else entirely. As a matter of fact, perhaps one of the most unmistakable stars, Betelgeuse, is significantly more noteworthy than our sun. For a long time, this star has confounded experts. However, in fact, something more disturbing has been occurring with Bug Jew, making investigators, as well as other very accomplished people, undoubtedly concerned. Oblige us in this video as we research the wonderful new about creepy crawly Jew, its coming decimation, precisely true to form by the James Webb Space Telescope, and how this new progress will influence our universe and our lives here on Earth, as explained by physicist Michio Kaku. Bug Juice is a colossal wonder, a tremendous star that has intrigued cosmologists for such a long time. A Greek stargazer named Antonius was the first to track down it. This star is so monstrous that it can be seen in the night sky from Earth, especially during winter. If you're into cosmology, you've no doubt seen or heard about this star. The becoming flushed orange star denotes the upper left shoulder of the Orion star grouping. So, you see, this star is outdated and up to this point, perhaps one of the most amazing stars in the night sky. Yet one thing about insect juice's brilliance is that it doesn't remain consistent. Rather, it varies. This change is one of the great properties of the star, but it isn't the only one. We ought to examine some of Bug Juice's particular properties. Most of the stars you find in the night sky are a long way from Earth. The closest star is 4.2 light-years from Earth. In case you don't fully understand how the term light-years gives a sense of distance, picture it this way. Consider moving at the speed of light for an entire year. It's been proven that light can cover a distance of 186,000 miles per second. Therefore, the distance light can cover in a year is equivalent to 1 light-year. If you do the math, you'll have billions of miles. So, when we say the nearest star is 4.2 light-years away, it means it is billions of miles from Earth. At any rate, examine this. A couple of stars are on a very basic level farther, and Bug Jew is one of them. Bug Jew is found around 600 light-years from Earth. So, if you somehow wind up going to it at the speed of light, it would still require 600 years. We can't move that fast. Not indeed. Even our speediest space rockets can. Yet, this star can still shine so brightly in our sky. If you're wondering how Bug Juice can be so amazing no matter its distance, that is a result of its unique characteristics like size and brightness. Creepy crawly Juice is many times more noteworthy than our sun. Its sweep is recognized to be on various occasions that of the sun. Unfortunately, it appears as a circle in space when using modern telescopes, while other stars appear as little points of light. This is believed to be an effect of the reactions at the external layers of its atmosphere. Concerning mass, Bug Juice weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by space specialists. 1 solar mass is equivalent to 2 by 10 to the power of 30 kilograms. Researchers can't pinpoint the particular mass of creepy crawly Juice since there are no other planetary bodies circling around it to analyze it with. And clearly, we can't measure it directly from here on Earth. Anyway, this makes insect juice many times heavier than our sun. The brilliance of insect juice goes from about 0 to 1.6. In simpler terms, insect juice is many times more brilliant than our sun. No huge shock, it was nicknamed a red Goliath. Anyway, the brilliance of creepy crawly Juice doesn't remain reliable. It varies. This change is due to its throbs, or, as such, creepy crawly Juice expands and contracts. When it expands, it gets brighter. When it contracts, it dims. This cycle can persist for 10 to 100 days, or even much longer. A novel property of insect juice is that its surface is covered in dark magnetic spots. The magnetic field here is far more grounded than at the average surface. However, the problem is these strong magnetic spots disrupt the flow of hot gas to the star's external surface, making the star cooler in these areas. The fact that creepy crawly Jew has so many of these spots compared to our sun makes sense of why it is cooler than our sun, no matter its size and brilliance. The sun also has its own dark magnetic spots, but those on Bug Jew are much bigger and significantly more numerous. To give you an idea, the spots on Bug Jew can be 2 times as extensive as Earth. Creepy crawly Jew also boasts a magnetic field that is many times stronger than that of the sun. This field is the reason that when seen through a telescope, the gases on the external layer of Bug Jew seem, by all accounts, to be moving around or bending. Insect juice has a surface temperature of around 3,500 K. This low temperature contributes to the low energy emitted by the star and its weak red color. Creepy crawly Jew is a red star, but it wasn't always red. It was yellowish around 1,000 years ago, similar to our sun. Over time, the color started changing to orange, red, and then around 600 years ago, it slowly began changing into the red star we know today. This fact has led researchers to believe that the star is developing. Insect juice produces as much as multiple times more energy than the sun. It would have been an irate competitor to Earth's sun if it weren't so far away. The fact that creepy crawly juice, which is 600 light-years away, can still be seen and connected with the naked eye around nighttime is very striking. Our sun is only 8.3 light-minutes from Earth. That's why it's so strong. If insect juice were only a little closer, we would also be able to see it during the daytime. However, if it were to replace the sun, it would consume or uproot the Earth and the other 4 planets near it because of its immense size. Other than whether or not it were to match the sun in size, it would still release more radiation. Bug Squeeze, also known as Bug Jew, is a very giant star located in the Orion constellation, about 600 light-years from Earth. Its monstrous size is one of its most striking parts. It is many times larger than our sun in terms of radius and could easily consume the orbit of Jupiter if placed at the center of our solar system. This incredible size allows creepy crawly Jew to appear as a disk rather than a point of light when viewed through powerful telescopes, in contrast to most other stars. Despite its huge size, Bug Jew isn't the most massive star. Its mass ranges from about 12 to 19 times that of the sun. This variety in mass estimates is due to the challenges in precisely measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Indeed, even at its lower estimated mass, Bug Jew remains a gigantic heavenly body. The brilliance of Scarab Juice is another. The brilliance of Bug Juice is another remarkable feature. Its luminosity, or brightness, is so immense that it outshines many other stars in our galaxy, despite being located 600 light-years away. This makes it one of the most visible stars in the night sky. When observed through powerful telescopes, it appears not as a simple point of light, but as a vast, glowing disk, further emphasizing its enormous size and energy output. In terms of structure, Bug Juice, like other massive stars, is undergoing an evolutionary process. It is currently in the red supergiant phase of its life cycle, which means that it has exhausted the hydrogen in its core and is now fusing heavier elements. This phase is marked by instability, causing the star to expand and contract over time. As it does so, it sheds massive amounts of energy and mass into space. However, this constant fluctuation isn't just an interesting scientific phenomenon. It is also an indication of the star's imminent fate. Bug Jew is expected to explode as a supernova at some point in the future. This cataclysmic event will release an enormous amount of energy, briefly outshining an entire galaxy and producing elements that will eventually contribute to the formation of new stars, planets, and even life. Interestingly, the process leading to a supernova is not a peaceful one. As the star reaches the end of its life, its core will collapse under the weight of its own gravity, triggering an explosion. This is the final stage in a massive star's evolution, and the resulting supernova can have far-reaching effects on its surroundings. The explosion will disperse heavy elements into space, enriching the interstellar medium with the building blocks for new stars and planets. Though the supernova event for Betelgeuse is not expected to occur for several million years, it is a stark reminder of the dynamic nature of the universe. Stars, like people, are born, live, and die, sometimes in a spectacularly violent fashion. Scientists continue to study stars like Betelgeuse in order to better understand the life cycle of stars, the forces that shape our galaxy, and the future of the universe itself. In summary, Betelgeuse is an extraordinary star that continues to captivate astronomers and enthusiasts alike. From its massive size to its unique magnetic properties, it is a fascinating object of study. Its eventual supernova will mark the end of its life, but it will also contribute to the cosmic recycling process that forms the raw materials for future stars and planetary systems. For now, we can only gaze up at the night sky and marvel at its brilliance, knowing that it is but one chapter in the vast and ever-changing story of the universe. Betelgeuse varies reliably over the long haul, with its splendor ranging from magnitude 0 to 1.6. For comparison, a magnitude 0 star is approximately 2.5 times brighter than a magnitude +1 star. At its brightest, Betelgeuse can be up to 100,000 times more luminous than our Sun. This variance is attributed to its pulsations, irregular expansions, and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for years, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it the distinctive red hue typical of red giant stars nearing the end of their life cycles. Life cycle and cosmic fate. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere exhibits complex physical phenomena, including dark magnetic spots where the magnetic field is stronger than in surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains an immense and energetic star, but it will ultimately meet its end in a tremendous supernova. Betelgeuse is approaching the end of its life, and its potential fate will be dramatic. When it runs out of fuel, it will undergo extreme fusion processes, creating heavier elements like helium and carbon. This will cause the star to expand to possibly even larger sizes, making it one of the largest stars visible in the night sky before it ends in a vast explosion. Supernova and beyond. The supernova will be a catastrophic event marking the death of a massive star. The force of the explosion is strong enough to momentarily outshine an entire galaxy. This phenomenon could send shockwaves through space. Betelgeuse's explosive end is expected to occur relatively soon in astronomical terms, possibly within the next 100,000 years, a brief span compared to the age of the universe. When Betelgeuse finally explodes, its outer layers will be ejected into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. The supernova will release vast amounts of energy, producing heavy elements like iron and nickel that are essential for the formation of planets and other celestial bodies. These elements will spread throughout the universe, enriching the interstellar medium and contributing to the birth of future stars and planets. Scientific observations. Recent observations of Betelgeuse have revealed unusual changes in its brightness, leading to speculation that the star may be nearing the edge of a supernova. However, it is difficult to predict exactly when this will occur. The James Webb Space Telescope, JWST, has provided new insights into Betelgeuse's behavior. Its infrared capabilities allow scientists to study the star's outer layers and magnetic fields in great detail. JWST's findings confirm the star's ongoing changes, including its irregular brightness and potential instability. These observations provide valuable information about the processes leading to a star's death, improving our understanding of stellar evolution. Legacy of Betelgeuse. Betelgeuse's eventual demise will have far-reaching implications for the universe. The supernova shockwave could trigger the formation of new stars in the surrounding region, fostering the cycle of stellar birth and death. Additionally, the elements created by the explosion will spread throughout space, contributing to the building blocks of future worlds. In the grand scheme of cosmic evolution, the death of Betelgeuse will not only mark the end of one of the most massive stars we can observe, but also pave the way for the next generation of celestial objects. While we won't be around to witness Betelgeuse's final moments, the study of this star offers invaluable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on Betelgeuse helps astronomers better understand the processes governing stellar birth, life, and death, offering a glimpse into the fate of other stars with similar characteristics. In the future, scientists hope to study Betelgeuse further using advanced technologies and space observatories. The data gathered from the star will continue to shape our understanding of astronomy, unlocking the mysteries of how stars evolve and what their explosive deaths mean for the universe. Betelgeuse, as a massive and dynamic star, is a crucial piece of the cosmic puzzle. Its eventual demise will be one of the most fascinating events in our universe's history. Yet, it is important to remember that the universe is constantly evolving. New stars are born every moment, and the energy released by supernovae like Betelgeuse ensures that the cycle of life and death in the universe continues. The legacy of Betelgeuse will live on, not just in the elements it creates, but also in the knowledge it provides to generations of astronomers. By studying stars like Betelgeuse, we can continue to unravel the mysteries of our universe, understanding more about the forces at work and our place within the cosmos. The significance of Betelgeuse in astronomy. Betelgeuse is not just a subject of curiosity for astronomers, but also a benchmark for understanding the later stages of stellar evolution. As a red supergiant, it offers a rare glimpse into the processes that massive stars undergo as they approach the end of their lifespans. By studying Betelgeuse, scientists can refine their models of stellar behavior, supernova mechanisms, and the formation of neutron stars or black holes. Moreover, Betelgeuse is relatively close to Earth, at a distance of about 640 light-years, making it an ideal candidate for observation. Its proximity allows researchers to monitor changes in real time with high precision, providing a wealth of data that would be challenging to obtain from more distant stars. Betelgeuse's role in cosmic recycling. The eventual supernova explosion of Betelgeuse will play a vital role in the cosmic recycling process. When a star of this magnitude explodes, it releases a vast array of heavy elements into space, seeding the surrounding regions with materials essential for the formation of new stars, planets, and even life. These heavy elements, such as carbon, oxygen, iron, and nickel, are the building blocks of planets and living organisms. In fact, every atom in our bodies was once part of a star that exploded billions of years ago. Betelgeuse's death will continue this cycle, contributing to the enrichment of the cosmos and ensuring the continuity of stellar evolution. Impact on observers on Earth. When Betelgeuse eventually goes supernova, it will likely be one of the most spectacular celestial events ever witnessed by humanity. The explosion could shine as brightly as the full moon and be visible even during the day for weeks or months. While the event would be awe-inspiring, it poses no direct threat to Earth due to the star's distance. This rare event will captivate not only professional astronomers, but also amateur stargazers worldwide. It will provide a once-in-a-lifetime opportunity to observe the death of a star in vivid detail, offering invaluable insights into the life cycles of massive stars. Lessons from Betelgeuse. The study of Betelgeuse highlights the dynamic and interconnected nature of the universe. It reminds us that even the largest and most powerful stars have finite lifespans, and their deaths are integral to the creation of new cosmic structures. The legacy of Betelgeuse will be immortalized in the elements it produces and the scientific knowledge it contributes to our understanding of the cosmos. As astronomers continue to monitor Betelgeuse and refine their predictions about its eventual demise, they are uncovering new layers of complexity in the processes that govern stellar life and death. These discoveries not only enhance our understanding of the universe, but also deepen our appreciation for the intricate forces that shape the cosmos.